Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in. Okay, reaction rate. So what is the rate of reaction? And that's how fast a reaction is going, how fast your definition is your reactants are becoming products. So you could have two different reactions. They could create the same amount of product, but the rate of reaction, that keyword rate, is how quickly that conversion from reactants to products is happening. What is the rate of reaction affected by? Temperature, pressure or / concentration, surface area and catalysts, and you need to learn those 4 different categories. Temperature, remember, it's to do with the kinetic energy of your particles. They have a larger kinetic energy the higher the temperature, so they're moving quicker, so they have these more frequent collisions. Remember, that really is the key here, these more frequent collisions. Pressure and concentration, that's talking about the number of particles in a given volume. So if there are more particles in a given volume, then they're going to have more frequent successful collisions. Surface area, how many of those particles are actually exposed to the collisions? Again, they would have more frequent successful collisions if more of those particles are exposed. And catalysts, this one's actually to do with lowering the activation energy. Remember, the activation energy is the energy required for the reaction to happen, for those reactants to turn into products. So if you can lower the activation energy, then you are going to have a larger proportion of more frequent successful collisions. That really is the phrase, and you can link any one of these 4 to those more frequent successful collisions. Okay, calculating rates of reaction. How do we calculate it? So you can do either the amount of product produced in a given time or the amount of reactant used up in a given time. And remember, these two are the same because of your conservation of mass. Using up that reactant's mass is equivalent to that product being made's mass. What units do reaction rates have? Well, this is quite an interesting one because they can have a range of different units, and you need to look at the particular question and you can deduce what the units might be, because the amount of product, we could be talking about mass, grams, kilograms, milligrams, whatever, or we could be talking about number of particles, moles, or we could be talking about a volume, especially if it's a gas. So centimeters cubed, decimeters cubed, milliliters, liters. And then time could be in seconds, but it could also be in minutes. So they can be quoted in whatever. But the point is like, if I was trying to work out the reaction rate in moles per second, then I'd need to make sure that the unit I was using for my amount of product was moles, and the unit I was using for my time is seconds. So they need to match, but they can be a range of different units. Investigating rate. So how do we measure amounts of a substance, and do we always need to measure an amount of a substance? So remember, it depends really what the substance is, and we can measure it in different ways. If it's a gas, we can measure that gas volume by using a syringe and taking a measurement on the syringe at different points in time. Or if it's a gas as well, we could measure a mass change. So we could put our experiment on a mass balance and something like a conical flask, and that mass is going into the air. So the amount that mass has changed will tell me how much gas has escaped or been produced. But we don't always need to measure an amount of substance. If you want to calculate a reaction rate, then you're going to need to do something like that. But you could just, if you've got a precipitate, for example, look at time taken for that cross to disappear, so time taken for that product to form. Solid Mg to disappear here, for example, in this magnesium and hydrochloric acid. A longer time means a slower rate.
How do we make investigation fair? Well, keep control variables the same. What are we changing and what are we measuring? Okay, so if you're changing the surface area of your reactants, then you must keep the concentration of your reactants the same. So everything else, concentration, you'd also need to keep the temperature the same, whether you did or didn't use catalyst. So everything else needs to stay the same. Okay, rate graphs. How do we plot a rate graph and what goes on the X and what goes on the Y? So time goes on the X and on the Y is what you measure. Maybe it's volume of gas produced, maybe it's mass of reactants or lost, or the mass of the products. Here in this particular graph, we've got total volume of hydrogen collected, and I've been given the unit centimetres cubed and the time in seconds. So remember, those can have different units. Time could have been in minutes, or maybe your volume could have been in decimeters cubed. These are just valid units for this graph. When has the reaction stopped? You're looking for where your line is flat and it's plateaued. It's at that point there first. If I go along to the bottom, each one of these squares is worth 2, so that must be 64, and remember seconds, so just make sure to read that unit off the bottom. What's the average rate of reaction in the first 20 seconds? So remember your average rate of reaction, this graph, the steepness of it tells me about your rate of reaction. So the steeper the graph at that point, the faster the rate of reaction. But since it said average here, this one's quite straightforward. I go up to my 20 and I go across to find the volume of hydrogen that had been collected within that 20 seconds, so in total. And that is 48 there, centimetres cubed, and then I just divide. 48 by 20, 2.4 centimetres cubed. And remember that second to the -1, that's just the equivalent of doing a dash per second, that -1 there. How do I calculate the rate of reaction exactly 20 seconds? This is a different question, because this isn't asking you to find some amount and divide it by the total time it took to get that amount. Now you want the rate of reaction that's happening exactly at that time. So what it's asking me is, what is the steepness of the graph at this time, 20 seconds? So remember, this is where we do our tangent. So draw your tangent in, and then you find the gradient of that tangent. So find 2 spots. I've got this triangle here, but I've drawn it onto 2 very clear spots on one of the grid lines, okay? 78 and 24 and 44 and and 0 are my 2 different points there. And I do 78 minus 24. Remember, that's my change in y. And then my change in x is 44 minus 0, so my change in x. So do my change in y divided by my change in x. 54 divided by 44 is 1.23 centimetres cubed per second.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Tips and tricks for this section. First one, frequency. When you're writing about how different things affect a rate of reaction, frequency of collisions. So number isn't quite enough. More successful, frequent collisions. You might see some strange units for rates of reaction. So remember, it'll always be an amount and it'll always be per unit time. And you can compare that to something more familiar like miles per hour. We know speed comes in loads of different units: meters per second, kilometers per hour, miles per hour, and it's the same for your rate of reaction. They're all valid, but you just need to check what your units are. Be precise when you're calculating your rates on the graph. They usually allow a range of answers, but the range isn't very big, so make sure you're really clear on exactly where you are on your x and y axis, and be really careful when you're drawing your tangents.